So to review some operations that was learned back in Algebra 2, we're going to review our operations with rational functions. So first we're going to review the FOIL and distributive property. Remember, the F stands for first, outer, inner, last. So we use this to multiply binomials together. So if you remember back from algebra, you're going to multiply your first terms together. So x times 2x is a 2x squared. Your outer terms is x times -1, which is a minus x. 1 times 2x is a 2x. And then finally your last terms, 1 times -1 is a -1. And then you want to check to combine your like terms. And as you can see, remember, like terms have the same variable with the same exponent. So we can add the coefficients together, -1 plus 2. So your final answer will be 2x squared plus x minus 1. Now, remember, just like we did with the factoring, you may also have bases that are no longer in terms of x's or letter, but in terms of a trig function, but you still apply the same operation, your first, outer, inner, last. So when you go to multiply sine theta plus 4 times sine theta minus 1, you can multiply sine times sine, which give you a sine squared theta. The outer term, sine times -1, is a negative sine theta. The inner terms, 4 times sine theta is a plus 4 in sine theta, and then 4 times -1 is a minus 4. And again, you have the same base that is a trig function of sine. Sine is both raised to the first power. So then you can combine them to be sine squared theta plus 3 sine theta minus 4. So just like with the factoring, if you want to do a substitution, let x be equal to sine theta, you can rewrite this as x plus 4 times x minus 1. You can FOIL in terms of x and then bring back in the sine in the end if you want to rewrite it that way. Now remember, a rational function is when there is a polynomial in the numerator and or the denominator. So that's what makes a rational function. One thing you learned last year is when you have a complex fraction. Remember, you need to simplify a complex fraction when there is a fraction in the numerator and or the denominator. Remember, you want to use the LCD method to simplify it. You find the least common denominator and then make sure you factor all the denominators first before you identify the LCD. So for example, if I give you these two fractions and I ask you what the least common denominator is, the first thing you want to do is factor this x squared minus 4. And that factors, that's a difference of squares, that factors into x plus 2, x minus 2. So when you identify the least common denominator, every factor has to be in the LCD. So notice in the denominator, the first fraction you have an x plus 2. That has to be in your LCD. You also have an x minus 2. That factor also has to make an appearance in the LCD. When you look at your second fraction, you have an x minus 2. That's already there. So the LCD then for between those two fractions is going to be x plus 2 and x minus 2. So when you look at a complex fraction using the LCD trick, what you want to do is you want to look at the fraction in the numerator and the fraction in the denominator and identify what the least common denominator is going to be. So notice the fraction in the numerator, this denominator is an x plus 4. So x plus 4 has to be in the LCD. When you look at the fraction in the denominator is an x minus 4. So x minus 4 also has to be in the LCD. So what you're going to do is then you're going to multiply each fraction by x plus 4, x minus 4. Remember, this is actually a fraction over 1. So the idea is when you multiply these fractions by the LCD, you should be able to cross-cancel a common factor. So I can cancel out that x plus 4 because I have an x plus 4 in the denominator and an x plus 4 in this LCD. What you're left with is a 3 times an x minus 4. So now notice, poof, in the numerator the LCD is gone. 5 over x minus 4, when you multiply by the LCD, you can cross-cancel that common factor of x minus 4. And what we're left with is we're left with a 5 times x plus 4. There is no common factors to cancel out, so it is okay to leave your answer like this. You can distribute the 3 and the 5, but you don't have to. So notice in number 7, Notice you have a fraction in the denominator. There is no fraction in the numerator. The only fraction in the denominator has a denominator of x. So your LCD is an x. So what you're going to do is you have to multiply everything by x because you want to keep your fraction equivalent. Remember, this x is actually a fraction over 1. So when you multiply 3 times x, that gives you a 3x over 2 over x times x over 1. The x's cross out, and you're just left with a 1 times 2, which is 2, plus 7x. When you look at number 8, notice you have a fraction in the numerator of x minus 4. So in the LCD, you're going to have an x minus 4. When you look at the denominator, you've got a 1, and you have 2 over x minus 4. The x minus 4 is already in the LCD. So I'm going to multiply everything by that x minus 4 over 1. Again, when you look at the numerator, 3 over x minus 4 times your LCD, the x minus 4 goes away. So I'm just with 3 times 1, which is a 3, over. And when you do this, you should end up with no more fractions in the numerator or the denominator. You still have to multiply the 1 by the x minus 4 to keep your fraction equivalent. Minus. Again, I have to multiply 2 over x minus 4 by the LCD. X minus 4s are going to go away, so I'm left with a 2. So when I combine like terms in the denominator, I'm left with 3 over x minus 6. So when you look at problem number 9, in problem number 9, notice you've got a 2x. Let's look at the numerator. One fraction has a 2x. In the denominator, the other one has a 4. So look at your coefficients first. The least common multiple, or the smallest number that 2 and 4 can divide into evenly, is going to be a 4. So in your LCD, you have to have a 4. You have an x to the first. So I know an x to the first has to be in the LCD. When you look at the denominator, we've already got the 2 and the 4 taken care of. But notice this has an x squared. So again, the least common multiple between x squared and x is going to be your x squared. So I'm going to multiply everything by 4x squared. Remember, 4x squared is actually a fraction over 1. So now when you multiply 4x squared by 1 over 2x, again, 2 goes into 4 2 times. X goes into x squared 1x times. So that's going to leave me with a 2x. Minus. You can cross cancel the 4's, and you're left with 1 times x squared, which is an x squared. Over 4x squared over 1 times 1 over 2x squared. Again, 2 goes into 4 2 times. The x squares cancel. Minus 4's cross cancel. X goes into x squared x times. Now you always want to make sure your fraction is in simplest form. So after you get done doing the LCD trick, what you need to do is factor wherever possible. I can factor an x out of the numerator. And then you can cancel out that common factor. Your final answer is going to be an x. So just like with the other problems, you also have to be able to simplify looking at your trig functions. So for example, we've got a fraction in the numerator, we've got a fraction in the denominator. So let's identify the LCD. Looking at the top, you have a sine theta minus 3. Sine theta minus 3 has to be in your LCD. When you look at the denominator, you have a fraction in the denominator, and that has a sine theta. So everything's going to get multiplied by that sine theta times sine theta minus 3. Again, if it makes you feel better, you can do a substitution, let x be equal to sine. So again, in the numerator, when you multiply the LCD by the fraction, the sine theta minus 3 is going to cancel. And I'm left with a sine theta times 5 minus sine theta. Over. When you look at the fraction on the bottom, again, you could cross cancel the sine thetas, and you're left with a sine theta minus 5 times sine theta minus 3. Now if you look right here, sine theta minus 5, 5 minus sine theta, they're all most common factors that you can cancel. However, notice this factor has a positive 5, the one on the bottom is a negative 5. This is a negative sign, this is a positive sign. So what you want to do is you want to factor out that -1, use that -1 trick. By factoring out a -1, what you're going to do is you're going to flip the signs of what's inside the parentheses. So now you can cross out those sine theta minus 5. So your final answer would be a negative sine theta over sine theta minus 3. If you look at number 13, remember, before you identify the least common denominator, what you want to do is factor any denominators if possible. Notice if you look at the fraction on the denominator, you can factor a 2 out of this using your GCF factoring. So now when you go to identify the LCD, you look at the fraction on the top, you have to have a cosine theta minus 3 as a part of your LCD. When you look at the fraction on the bottom, you already have the cosine theta minus 3, but you need to include the 2. So now when you multiply everything by your LCD, so again, in the numerator, the cosine theta minus 3's cancel, and you're left with a 2 times 2, which is a 4, over 1 times your LCD is just going to leave you with that LCD. Make sure you bring the subtraction sign. The 2's are going to cross cancel, so the cosine theta minus 3's, and you're left with a 5. Now you do need to distribute and combine like terms in the denominator, so when I distribute the 2, that'll give me a 2 cosine theta minus 6 minus 5. So your final answer will be 4 over 2 cosine theta minus 11. So just like in number 14, you've got 4 fractions. You've got to factor this denominator first. That factors into, that's a difference of squares. Sine squared is a perfect square. 4 is a perfect square. So sine theta minus 2, sine theta plus 2, minus 2 over sine theta minus 2, over 1 over sine theta plus 2 over sine theta minus 2. So the LCD then, you got a sine theta minus 2, a sine theta plus 2. So both those factors have to make an appearance in the LCD. So when you multiply 4 over sine theta minus 2 sine theta plus 2, both these factors are going to cancel with the LCD, so you're left with a 4. Minus, when you multiply 2 over sine theta minus 2 times your LCD, just the sine theta minus 2's are going to cancel. So you're left with minus a 2 times sine theta plus 2 over 1 over sine theta plus 2 times your LCD. Just the sine theta plus 2's are going to cancel. You're left with a sine theta minus 2 plus 2 over sine theta minus 2. When you multiply by the LCD, just the sine theta minus 2 will cancel. You're left with a 2 times sine theta plus 2. Then you have to clean up the numerator and the denominator. So I have to distribute the negative 2. So 4 minus 2 sine theta minus 4 over sine theta minus 2 plus 2 sine theta plus 4. 4 minus 4 cancels, so I'm left with a negative 2 on the top. Sine theta plus 2 sine theta gives me a 3 sine theta plus 2. Again, you can always change your signs into x's and then substitute back in the end.